Good morning, everyone on YouTube. Before we begin today's session, could you please let me know if I am audible? Okay, great. Thank you for the confirmation, Avinash. Good morning, everyone, and welcome to today's Academy session presented by Formula Bharat. This morning, we have Pradeep Kumar Keloth of Bosch, GmbH, who shall be presenting on the topic Overview of EV Systems and Components. Mr. Keloth shall be covering sections including the battery, power electronic components, inverter, DC and EV charger, and e-machine in this presentation. The contents are geared towards teams interested in pursuing the EV category in Formula Student in the future. So without further ado, I'd like to invite Mr. Pradeep Kumar Keloth to the stage. This session is sponsored by Robert Bosch Engineering and Business Solutions Private Limited. Pradeep, please go ahead.
Hi, good morning, all of you.
Good morning.
Am I audible?
Yes, clear.
Okay, just a minute. Let me share my. Is it visible, my slide?
Yes, your screen is visible and your slide is visible as well.
Okay. Okay, good morning once again. So thanks to the organizing committee for inviting for this talk. So is it my picture also visible?
Yes, sir.
Yeah, okay.
You might just need to go a little bit behind because right now it's and put your screen down a little. There you go. That I think this is much better. Great.
Just a minute.
Sure.
Okay, so good morning once again. I will give you an overview of electric vehicle components and overview level. And I'll also give some more informations related to what are the different components, how the electric vehicle works, what are our challenges, etc. So to give you an example, I have taken a Fiat 500e electric vehicle. So just an example to see what are the essential components in the system. And this is a vehicle which is meant for city drive, where you are not going out out of city, so that whatever range it is getting from the given battery pack is well charged using a slow charger, and there is no problem related to charging, etc. So this vehicle, you can see, let me start with the battery pack, which is one of the most important component here. You can see the screen battery pack here, and you can see that one of the problem with the battery pack is because of the limited energy density compared with a petrol vehicle. So you will have a large weight here. It's a huge weight. And one of the important constraint here is that how this particular weight need to be distributed. It cannot be a small size concentrated weight. It need to be distributed so that the center of gravity of the vehicle will remain on the same place without battery. So that the overall vehicle stability will be established. That is the reason why you can see that it is a little bit longer and with less thickness and distributed over the bottom portion of the car. And this vehicle is, this battery is lithium-ion based. We'll have a little bit look at it, what is lithium-ion, why we should go for lithium-ion. And it has a capacity of 24 kilowatt hour. So this is regarding the battery. You can see the right hand side here, the battery pack, and you can see various lithium-ion cells. Actually, typically a lithium-ion individual cell will have a voltage level of around 3.5 to 4 volt. And if you wanted to get this particular, the total voltage required is 364 volt. You can see it here, 364. The battery rating is 24 kilowatt hour, 364 volt. And if individually the lithium-ion typically gives 3.5 to 4 volt, so that means 97 cells need to be connected in series to get that 364 volt. And you can see that the cells are arranged here in connected in series. So you will get a voltage of 364 volt. The most important thing with respect to lithium-ion battery is that you require a electronic circuit called BMS system, battery management system. And you can see that it is projecting here. You can see this battery pack and the battery management system over there. Battery management system is an electronic circuitry which monitors the battery pack. So it will take individual cell has its voltage measurement, and this voltage measured are passed on to the electronic system, BMS system, as well as all these cells are connected in series. So you require only typically only one current sensor, but typically we provide two current sensors for redundancy purpose. So this will give you the current flowing through the cell. In addition to voltage and current, so we also will measure the temperature. So because why this BMS system is required is, it is extremely important that lithium-ion cells, individual cells, operate well within the voltage and current and temperature ranges. So if by any chance, if this goes beyond, then there is a possibility that the lithium-ion will fail, and it can also result in hazardous conditions. It is extremely important that to safely operate the lithium-ion battery, we need to continuously monitor the current, individual voltage in each of the cells, because voltage is measured at each cell voltage. And then you also need to have the temperature. Temperature, unfortunately, we cannot measure the temperature at each and every cell. So typically we take 3 temperature sensors mounted on the battery pack, and then we'll take the average of that particular temperature and to see that how this particular temperature is, because actually lithium-ion cell performance is a strong function of temperature. That is one part. And if the temperature goes beyond a particular limit, we don't allow, typically the temperature of lithium-ion cell goes beyond, say, 65 degrees centigrade. So in case this particular temperature exceeds, then immediately the battery will be disconnected from the car. and so that the failure of the battery does not happen. So we will see some more safety conditions in the coming slides, because somebody will ask the question, okay, what will happen if a crash happens, and what will happen to the battery safety during that time. It is coming in the coming slides. I will explain you during that time. So here you can see that so these are all the range, and it can go up to top speed of 85 miles per hour, not kilometer per hour. So now regarding the battery. So now from the battery, it is DC voltage, and then you are driving the car using a AC motor. So it is an 83 kilowatt three-phase AC motor. So this motor comes under the classification of PMSM, permanent magnet synchronous machine. So but this particular machine works on AC. So whereas the energy is coming from battery as a DC source. So we need to have a DC to AC converter, and this is what actually the inverter module does. So the power inverter module here converts the DC voltage, DC power supply into AC, so that it is driving the AC motor. So we have identified three components now. One is the battery, the other one is the power inverter module, and third one is the electrical machine. In fact, these three are the most important components in the electric vehicle. So here you can see the driving forces, driving process. You can see you have the energy storage, that is the battery, and from there the energy goes to the inverter. So strictly it is a current controlled inverter. So you change the current, so you'll get more torque in the motor. Again, this part, more detail will come in the coming slide. And then you have the PMSM motor, and then goes to the transmission system, and then it goes for driving. The power is transferred to the wheel. So now, one important property of electric vehicle is related to regenerative braking. You must be knowing about it. So conventional vehicle can have what you call a friction braking, where whenever you do the braking, the energy is lost. It is dissipated as heat, and then it is lost. But in the electric vehicle, we have a feature called regenerative braking. So if you don't need a sudden brake, in case of a real accident conditions, when you apply a sudden brake, so then the entire braking forces will come from friction energy, because there the intention is safety and then not to retrieve the energy. But if you are doing braking in a slow process, that means you are only applying braking in a very slow manner, so that you have some braking distance depending on that condition. What happens is that the braking module, in addition to the friction braking, as also have additional components to support the regenerative braking. So what happens is that the kinetic energy of the electric vehicle, when it is moving and when you are applying slow brake, so what happens is it goes in the reverse direction, and the motor, which was motoring during the normal operating condition, will turn to a generator. So this particular generator, whatever energy which is generated, goes into charging the battery. So that means during braking, it is a possibility that you can conserve some part of this braking energy into electrical energy to charge the battery. So this is not possible in our conventional braking system in the conventional IC engine vehicle. So then we have on the left-hand side the power supply. So typically, if this is a AC power charging, so then you need to have a onboard charger here, and this particular charger will convert the AC to DC, and this will charge the battery, and a lot of standards are available for this charger. So we spoke about two additional components, and one component is the charger. So for this particular vehicle, we use 6.6 kilowatt onboard charger module, which is also available here, which can be plugged into AC power supply. And using different kind of standards are available, different kind of connectors are available. Depending upon those standards and connectors, we can charge the vehicle connecting to the power grid. Okay, so we have completed almost all the components here. So let us go to details of each of this. One more component is there which is missed, which I will come in the next slide. So this particular component is called DC-DC converter, which is a very important component. So I'll explain what is the purpose of DC-DC converter. In a typical IC engine vehicle, so what you're showing here, this is an IC engine vehicle. So you can see that this is the drive shaft. Okay, so when the drive shaft is there, there is an alternator. You can see that in all our conventional IC engine based vehicle, there is an alternator. So this alternator takes the mechanical power from the drive shaft and then convert it into electric power. And this electric power in the conventional system, you can see the AC alternator here, is used to charge your 12-volt battery. The battery I'm talking about here is 12-volt battery, which is available in IC engine based vehicle. This 12-volt battery is available even in the electric vehicle, in addition to the high voltage battery. So what the purpose of this 12-volt battery is to supply all the small vehicle loads, the wiper systems, the power windows, and so many small electrical equipments are there in the car. The truck, the signals, the direction signals, the lamps, direction lamps. All this is operated from 12-volt battery, and this particular battery will get discharged. So as and when the current goes through it and supply various vehicle loads. So what happens is this particular alternator will be keeping on charging your 12-volt battery. So this battery and the vehicle loads, they remains the same, whether it is IC engine or electric vehicle. Probably for electric vehicle, you may have some more additional loads. Typically, this varies. This load varies from 1.5 kilowatt to 3 kilowatt, depending upon what are the accessories available in your car. So what happens in an electric vehicle is that we'll replace this particular alternator. You don't need this alternator. Okay. So what it does is that you can see the picture here. So you have high voltage battery here. This is typically 400 volt. In this particular car, it is 384 volt. So this particular voltage is DC, and then it goes to DC to AC conversion and goes to the motor in the normal path. So we tap this particular high voltage. So this is 384 volt here, and then we put a DC to DC converter. So basically DC to DC, the name suggests that it is converting DC voltage into DC, kind of stepping down happening here. And the secondary side of the DC-DC is approximately 14 volt or something, 14, so that it can be connected to 12-volt battery so that the battery can be charged. So thereby, you are eliminating the alternator in the conventional vehicle. So by a static device called DC-DC, so thereby you are eliminating some moving mechanisms, and DC-DC is much more cheaper than the alternator. So in every electric vehicle, you will find this DC-DC converter. So this is the another important component in an electric vehicle. So now coming back to the previous slide. So we have seen, in addition, so DC-DC is not shown in this slide, but DC-DC converter is another component. So now probably I assume that you got what are all the, at least the important components in the electric vehicle, including DC-DC converter. So now we'll have some look at what is the reason for moving to the electric vehicle. See, one of the most important reason is that, and I also will talk about what are the challenges. So one of the most important reason for going for electric vehicle, as you know, that one is that CO2 emission coming from any fuel which is carbon based, any carbon based fossil fuel. So we are using here either diesel or petrol, which is a carbon based fuel, and definitely when the combustion happens, and there will be a lot of CO2 emission, and the CO2 emission is greenhouse gas, and naturally you can see that there is a stringent rule to control the CO2 emission so as to avoid all this kind of greenhouse effect. And you know that I am not going into the detail, so you know that what will happen, the severe impact on the environment So when the CO2 goes beyond a particular, so actually for all the vehicle, stringent standards are coming to reduce the CO2 emission from the vehicle. So various methods are there. When you go for electric vehicle, the CO2 emission is completely zero. And maybe you can go from IC engine to a pure electric vehicle in stages. And maybe you can go for mild hybrid, you can go for strong hybrid, you can go for plug-in hybrid. So in each of this particular system, when you are going for, your CO2 emission will keep on coming down. And finally, when it becomes electric vehicle, so the CO2 emission is zero. Is zero from the vehicle, but we need to look at the overall picture. I'll come to that. The second driver for electric vehicle is other air pollution. Apart from CO2, you will have a lot of emission happening, carbon monoxide and NOx and particulate. A lot of things are coming out of the tailpipe of the car. And this also is causing environment pollution. And this particular pollution also will be zero when it comes to an electric vehicle. And the severity of this is in such a way that 2.6 million people in India on an average dies because of air pollution, mainly coming from this particular data is only for the vehicle. Because actually you can have the air pollution coming from industry and everywhere. Approximately 10% of the CO2 emission worldwide is coming from the passenger car segment, and around 24% is coming from the complete transport industry. So naturally, we need to avoid this particular air pollution, and this is the second driver. And third part is related to specific to India, because we have a huge import on oil bills. So it is approximately 2019, it is somewhere around 120 billion USD of oil import. Is yearly expenditure, is one of the major expenditure for government to import the oil. So we need to have that reduce this particular import oil. So dependency on the IC engine based vehicles need to be reduced. So this is the specific driving factor for India. So now the question is, all this is from environment, government policies and all that, how the emissions need to be reduced, how the CO2 need to be reduced, but what is the benefit for the user, the end user? So the main benefit for the end user is, you can see the IC engine here. It is quite complex. You see that, okay, I'm not here, it is the highlighted portion is only the alternator, but you can see that you can imagine about an IC engine. You have an extremely complex the IC engine systems, so which has a lot of moving parts, maybe more than 20,000 to 2,000 moving parts in the system, very complex system. And understanding the combustion process, optimizing it, and the different techniques available for optimizing the combustion systems. And then you have exhaust after treatment systems, you have the air systems, you have the fuel injection systems. So all each of the systems are so complex, and the entire system is very, very complex. Whereas we have seen in the electric vehicle, it is very, very simple. So we have very less components, very less moving parts, and naturally you can see that the overall system has very less maintenance, and whatever the maintenance which is required is very minimum. And so that it is definitely a value add for the end user. I'll also come to explain you what are the difficulties with the electric vehicle, and that is our one topic, and then how we want to address those difficulties. The other part related to the electric vehicle is the fuel cost. On a equivalent analysis, you can see that the electricity cost is definitely much lower to drive an electric vehicle, and it is on an equivalent basis. It is calculated, it can be as low as 7 to 10 times small, is lower compared with petrol or diesel. The problem here is, okay, the advantage here is that the electricity cost in future is going to come down still further. Unfortunately, globally, the oil prices are coming down for the policy decisions. You can see that in India, it is going the other way around. It is almost touched 100 rupees now. And okay, but globally the oil prices are coming down, and in spite of that, the electricity fuel is still cheaper. And you can also see that the electricity production coming from solar energy, all the renewable energy sources is also increasing, and the price is reducing. So at some point of time, we'll be able to generate electricity from renewable energy sources, so that the overall CO2, the footprint will be again under control. See, the other part is with respect to the kind of drivability what you will get. The torque speed characteristics of electric motor, and of course, unfortunately, I don't have it. Maybe it is there in the coming slide. So, but I can explain you. The torque speed characteristics of an electric vehicle is much better than the IC engine. So you will get from a synchronous machine. So you will get a constant torque, very high torque, including the starting torque. Of course, synchronous machines are traditionally they are not self-starting motors. You don't have starting torque in it, but actually through some control systems called field-oriented control, so we can get high starting torque from a synchronous machine. For a large speed range, this particular torque will remain very high, and beyond a particular speed, when it gets into power mode, the torque starts coming down. I think I have a slide in the coming slides. I'll be able to tell you that. But for IC engine, the torque speed characteristics is completely different. Okay, so you don't get a high starting torque. So the electric vehicle, the moment you start, you are getting a very high torque. So you can really go with the high power right from beginning. So this definitely the user will definitely enjoy this. And most important thing is IC engine efficiency for a IC engine based vehicle is somewhere around 20%. So whereas you have very high efficiency in the electric vehicles, maybe close to around 85 to 90%. Of course, there are some disclaimer there. So under certain conditions, efficiency of the electric motor can go down, but definitely at least 3 to 4 times efficient than an AC engine. So all these are an attractive factor for the end user also to go for electric vehicles. But there is a catch. So the catch is related to the battery. Okay. So the only thing what is, in my view, preventing people to go for electric vehicles is due to the battery. So one thing is related to the cost. Cost is high. In fact, 40% of the cost of the electric vehicle is coming from the battery. Okay. So one is cost. Second is technology associated with this. Endurance, how long it will last, and what will happen to the battery life, what is happening to the battery while driving, how fast it is deteriorating, and so many things. And the last one and most important, safety. As I already mentioned, lithium-ion battery with a BMS system, you don't have to worry about the safety as long as the every parameters, current, voltage, temperatures, everything is well maintained. So there is no problem. But the cost is the biggest problem as of now. So what happens is that going forward, the every year the battery cost is coming down, and you can see that Tesla is going for bulk manufacturing of the battery. Tesla is entered into India as well, and we can safely assume that they are going to have a battery plant in India also. So in this particular case, when you bulk manufacture, the cost can come down further. But the technology cost of the batteries anyway is keeping on coming down year after the year. Maybe in another 2 to 3 years of time, the cost of the electric vehicle will become equal to that of an AC vehicle. At least we can expect that in 4 years. And even today, if you look at very carefully, if you do the analysis, there is a price parity. This is coming through government policy. So what is happening is that now there is a government policy in India is announced that battery and electric vehicle can be purchased separately. That means battery can be completely isolated from the vehicle. And then how does it work is that you buy the vehicle, only the vehicle without battery. So what happens is, when you buy the vehicle without battery, as I mentioned, 40% of the cost is coming from the battery. So today, if you look at Tata e-Nexon vehicle, of course, they are not gone for this particular policy. Government policy is announced. Now I think it will start getting implemented in the coming years. So now today you cannot buy a Tata e-Nexon vehicle without battery. So it is not yet implemented. But once it is implemented, the current Tata Nexon vehicle is around 15 lakhs. So probably you will get the Tata e-Nexon vehicle, say 40% lesser cost. If assume that approximately 5 lakhs is the cost of the battery, so you'll get that vehicle at 10 lakhs. And the 10 lakhs e-Nexon vehicle is, there is a price parity with respect to your IC engine based vehicle. So it is either at the same level or it may be even a lower price. What happened to batteries? Battery, you shift from capital cost to operational cost. That means there are energy providers. So maybe Sun Mobility is one such player in India. So you can lease the battery from them and then pay them an yearly cost. Okay. So what happens is that battery is coming as an operational cost, where you have to pay the lease amount for the battery on a yearly basis. Now you add all the operational cost. You are getting a lot of saving from the fuel. The more you drive, the better will be the saving. So if you are driving, let us say the vehicle is being driven in 100 kilometers, let us say per day. So maybe some fleet owners, all that. So what happens? Your fuel cost of petrol, you can multiply 100 kilometers and you can see that how much, depending upon the energy density of the petrol. And then you see that, as I mentioned, 7 to 10 times the electricity cost is lower compared with the petrol. And then you also try to include the maintenance cost. Maintenance of electric vehicle is very less. You add all the things together and look at the total cost of ownership, plus add to that, you can also add what are the subsidies you are getting, tax benefit you are getting, road tax benefit, whatever you are getting. If you put all these things together, you can see that even today, so there is a price parity between the electric vehicles and the AC engine based vehicle. So, but of course, this particular scheme, whatever government announced, has to be implemented. That means vehicle without battery and things like that. Okay, that means, so we are near in terms of cost. There will be so many mechanisms in which it can be taken care. And on top of that, you can also see that the technology cost of the batteries coming down. And on top of that, you can see that power generated from solar energy has come down drastically. So now today you can get power from solar much cheaper than from a thermal power plant already. Because last 2010 to 2020, in the last 10 years, the cost coming from the solar power is already reduced by 80%. And this will be further reducing in the coming years, so that you are getting the electricity from renewable energy sources itself. But solar has an important drawback. That means even though you can generate as much power from solar, and then government has a plan to generate 100 gigawatt of solar power by 2022. And we are already at somewhere around 50 gigawatt or maybe around some 60 gigawatt. I don't remember exactly. So, but actually 100 gigawatt is on target by 2022. But the biggest drawback of solar power is that it is available only during daytime. So when it is available only during daytime, so you need to have some mechanism to have this particular power continuity during the night. And naturally, you need some kind of a storage there as well. So what is happening is that for those storages, lithium-ion batteries are more than enough. That is one way of storing. Another way of storing, there are so many ways of storage. Maybe energy storage itself is a very big area in the coming years. So another important storage mechanism is that you can use during morning time, whatever power coming from the solar, you can use it for electrolysis of the water. Because electrolyzing the water requires a lot of electricity, that you can take it from the solar power, and then you generate hydrogen. So the hydrogen is going to be future fuel. So lithium is now And then many people are predicting future fuel can be hydrogen, or it can be mix of lithium and hydrogen. And a lot of research is going on even to replace lithium in the lithium battery. And then people are talking about sodium air, ion air. So many technologies are coming. But the thing is that it will take good amount of time to get matured. Okay. So lithium ion, if you look at the first lithium's commercial production of lithium ion happened in 1991 by Sony, but that is for laptop and camera and that kind of applications. And it slowly entered into the high power requirement for electric vehicle as well. So that means you can see that once a new technology is developed, it will take some time to mature. So even if somebody is coming with a non-lithium based battery, so it will take some time to mature, and a lot of things are happening in the research lab. A lot of things are getting reported, but it will take some time to mature. So what I want to say is that the technology related to the batteries is evolving, and ultimately what happens is that the same technology goes for grid storage. That means during the daytime when solar is available, when different kind of technology is available with the battery, so your storing will become easier. And parallelly, what happens is that the hydrogen that is getting produced through electrolysis can be used in fuel cell. And currently, today, if you look at the fuel cells are very costly. So fuel cell require hydrogen as the fuel. And so there, what happens is
Sir, sorry. Just wanted to check, is your slide moving, or was it?
no. I think
Okay,
slide
okay.
is slide. I'm not changing the slide. I'm giving you
I just
some.
wanted to make sure that we weren't
Okay,
missing
okay.
out
Good
on
that
anything.
you did it. So good
Yeah.
that you did it.
Please go ahead.
Actually, I just want to ask you: this 1 hour is a hard stop, or is it a little bit I can go to take the
Maybe
questions?
15 more minutes after that, because at 12:30 we have the award ceremony for the
Okay,
event.
fine. Yeah, fine. I think
Thank you.
probably I may not be able to go through the entire slide, but I'm giving you
Okay,
the overall picture. Yeah. So
sure.
slides I'm not moving. I'll tell you.
Okay,
Okay.
sure. Okay, great. Thank you. Thank you. Sorry about that.
So now coming to the fuel cell. Okay, so fuel cell today is very costly. Okay, so say for example, if I take a typical fuel cell required equivalent of 24 kilowatt hour battery, which you have seen in our example vehicle here. So that means I'm moving the slide now.
Yes.
So the vehicle which explained, the Audi vehicle, the equivalent, if you want to convert that particular vehicle into a fuel cell based vehicle, the cost will be around 70 lakhs. Okay, so you can assume that today the fuel cell technology, even though it is available, but it is very costly. And today the plan is to use fuel cell based vehicles only for the commercial applications. So commercial vehicles. So that means what happens is that commercial vehicle has to travel a long distance, very long distance. And during that particular very long distance, whatever money you are spending on petrol or diesel or whatever, and somewhere that particular parity will happen with respect to fuel. So suppose if you are driving the vehicle only 10 kilometer or 20 kilometer per day, and then if you are going for fuel cell vehicle, that is not commercial vehicle. It's not commercially viable in the today's scenario. But hydrogen is going to be a future fuel, and you can also use hydrogen for combustion for IC engine. So hydrogen as a fuel carrier, it can be used for many other applications. So I'm changing the slide now. So let us go a little bit detail with respect to the lithium ion. So lithium ion battery, you can see the requirement is it should have a very high specific energy. It have high energy density. So because if you look at the energy density of petrol is around 12,000 watt hour per kg. And whereas for the best of lithium ion, it can be somewhere close to 300. So it is very less. And one of the technology which is going to happen in lithium ion batteries, that keep on changing the battery chemistry so that you can get at least 1000 watt-hour per kg in the next 2 to 3 years. So this is the target. So you can see that recently Tesla announced the battery day, and what they did is that they changed the graphite available in the negative electrode. So I'll come that in the coming slide. A little bit of silicon is added. It is known that okay, if you add silicon along with the graphite in the electrode material, it is possible to have higher energy density. But the problem with the silicon is that whenever the battery undergoes charging and discharge, there will be a kind of a volume expansion happening in the silicon, which will destroy the battery. So the idea is that how to have some minimum kind of a silicon. In fact, Tesla announced they have added some percentage of silicon. I'm not very sure how much, and they were able to get some additional energy density. They also changed the what you call the form factor of the battery. So they changed the size of the, so Tesla is going for cylindrical shaped battery cells. So they changed the size of the cylindrical cell. Thereby, I think they achieved something like 30% additional specific energy density. So, but still, this is not enough. The petrol energy density is far away, far high. So, but the research is going on, keeping on increasing the specific energy density. So here you can see that in this particular slide, the volumetric energy density per kilowatt hour is on the y-axis, and specific energy density is on the x-axis. You can see the conventional rechargeable battery, lead acid, nickel cadmium batteries, and nickel metal hydrolysis batteries. All these particular conventionally available rechargeable batteries are behind the lithium-ion. So you can see if you look at the lithium lead acid, so you are getting only 50 watt-hour per kg. And not only that, its volumetric density is somewhere around 50. That means it will have very huge weight, very huge size for a given power. So as you go up the y-axis, the size of the battery will come down, and thereby the weight. And when you go to the right-hand side more on the x-axis, the specific energy density will increase. So you can see lithium-ion is coming far above the conventional lead acid or nickel cadmium batteries. So this is the advantage of lithium-ion. But the problem is lithium-ion is much costlier. It is at least it is 5 to 6 times costlier than a lead acid battery, which is typically used, the 12-volt battery in your automotive. The down below, you can see that, of course, I'm sorry that this slide is only up to 2015. So you can see that the cost of the lithium-ion per kilowatt hour is coming down yearly. And you can see 2020, it has reached somewhere 150 USD per kilowatt hour. And it is expected that it will reach 100 USD per kilowatt hour sometime in 2022 or 2023. And that is where actually people expect the price parity will happen, the battery cost will come, and the electric vehicle cost will become almost equal to the IC engine cost during another 2 to 3 years of time. As I mentioned, with the different business models, it is a little bit, it is achieved even today. So maybe you can skip this particular slide for want of time. Actually, here it is talking about how fast you can charge it, okay, versus the energy density. So the new lithium-ion battery is somewhere here. So the existing lithium-ion battery is somewhere here in this particular bubble and in this particular bubble. And maybe with additional research and all that, we will reach the new lithium-ion battery in this particular bubble. So wherein you have higher energy density as well as shorter time for recharging. Because the current lithium-ion technology, if you try to fast charge it, so the temperature rise inside the battery, the system will not be able to take care, and battery failure will happen. And naturally, the number of times you can do fast charging with the current technology is very, very limited. So naturally, people are going for further expanding the lithium-ion battery chemistry so that you will get higher density, and then you will get lesser time to recharge, and it's not it should be cost effective, and also it should be safe. So there are so many dimensions you need to look at when the research in lithium-ion battery is going on. So I'm moving my slide. So I don't go into too much detail here. Want of time, there are a lot of materials available, how the lithium-ion works, but very briefly I'll explain about what it is. So you can see that the positive electrode is on the left-hand side, and it is this actually the battery has two electrode, positive electrode, negative electrode, and the electrolyte as the main component, and then you can also have the separator. So these are all the four major components in a battery. So very briefly, you can see why lithium-ion, because lithium-ion has a free electron which is loosely bonded, and you have the lithium in oxide format. So different manganese oxide, LMO. So depending upon which one is used as positive electrode, the battery chemistry changes. So we call it as LFP, LMO, LMNO, LCO, NMC, NCA, and some of these particular batteries are chemistries used for our laptop and cameras and all that. LFP, NMC, LMO. So these are all used for automotive applications. It can carry the higher current, and it can also do some kind of charging and all that. So it is applicable for high discharge current, which is required for automotive applications, whereas your laptop or camera does not require that much amount of current. So the basic principle here is that you have lithium oxide here on the left hand side, that is positive electrode, where the electrons are freely moving around because it is not strongly bonded with the atom of this LMO. And you also have, when in a lithium ion, when electrons are separated, you will have lithium ion. Lithium ion plus electron will give you lithium. So you will have lithium ions Li plus, you can say. So plus because one electron is moved out. So Li plus and electrons are freely available here. What is required is that you want the electrons to flow in the external circuit and lithium to move through the electrolyte to the graphite. So that means during discharge, when the battery is discharging, when it is giving power, the electrons move out from this particular positive electrode. It goes through the external circuit, come back to graphite. Okay, so lithium Li plus, which is available here, will move from positive electrode to negative electrode. And the invention of graphite is one of the very big invention which has happened in lithium ion battery, because graphite has the structural properties such a way that there are a lot of spaces in between this particular graphite structure where this lithium ion will come and stays there. It stays there. Okay, and when entire lithium ion has moved from left side to right side, we can say that the battery is nearly discharged. Now you have to charge it. So when you are charging, so you will apply a battery here, and the positive terminal will be connected here and negative terminal will be connected here. So then what happens is the lithium ion from graphite, which is stored over here, will move in the opposite direction through the electrolyte. It reaches here, and electrons goes in the reverse direction. So because actually electron is supplied by the charging system. So what happens is during charging and discharging, lithium goes from one direction to the other. Electrons moves in the opposite direction. So this is what is going on happening. So the electrolyte will not allow the electrons to flow from one electrode to the other. And you have something called a separator also. So this separator is another invention, another major invention. So what this particular separator does is that it allows lithium ion to penetrate that separator and moves, because lithium ion has to move from one electrode to the other. Okay, so this separator will allow the lithium ion to go through that, but at the same time, electrically it isolate both of these electrodes. By any chance, if the vehicle crashes and the battery crushes, and if this particular positive electrode and negative electrode comes together, it results a short circuit, and then that is how the battery catches fire. So, but this particular separator, what happens is that it try to separate. In the normal condition, definitely it will separate these two electrodes electrically, but it allows the lithium ions to go through. So invention of such a separator, I don't remember the exact material used for it. It is available in literature, but invention of that particular separator is another major invention happened in the lithium-ion battery. So that means there are two major inventions. One is graphite. Graphite added with some chemicals, which is very secret. People will not reveal it. So the reason is such a modified graphite has the ability to store the lithium ion coming from the positive electrode to negative electrode when the battery is discharging. So the more the lithium ion you can hold, the more will be the energy density of the battery. So that means the research is going on, keeping on finding this particular material. Should I use, as I mentioned earlier, graphite? Graphene is another form of graphite. So graphene is also in the research state. Adding additional silicon into the graphite is another way that you can hold more lithium ions. More lithium ions are held, more will be the energy density. As Tesla is announced that with some percentage of silicon addition, they are able to get additional energy density. And this is a research which is going on. So this I already explained. I can move it. You can see the separator here. And you can see that what is happening in discharge and what is happening in charge. During charging, you are connecting the external source. So you have the electron flow happening from the external charger and lithium ions moving in the opposite direction. So this is how the battery works. And you can see that there are different raw materials available. And these raw materials, depending upon the battery chemistry, is forming a cell. And so many cells. I said that the cell voltage may be 3.5 to 4 volt, and you can add the cells in series of parallel. Mostly they are connected in series only. In some cases, to get more current rating, people are connecting it parallel. But once you have a series parallel combination, it is extremely difficult to handle it. So you handle the cells connected in series and parallel. You have modules, and these modules are put it into the battery pack, finally forming the battery. So now the question is that these particular different materials, nickels are added, cobalts are added for different purposes. Silicons are added, I already mentioned. So addition of this particular additional material, to what extent you have to add, changes the overall performance of the battery. So here you can see that different chemistry. So what I want to highlight, because of lack of time, is one is that you can see LFP here, which is probably considered the most safest battery chemistry, but it has very less specific energy, and cost everywhere is moderate. So is high on high side, and then you can also see LFP having high specific power. So you can see NMC, which is another chemistry which is used for automotive purpose. It has very high specific energy. Safety is a little bit compromised as compared with LFP, but that means NMC need to have some additional features in the BMS system to ensure that the battery is operating safely. So depending upon different chemistry, so we have to look at the BMS systems, and you need to make sure that batteries are operating safely. So I'm just looking at my time. It is already 5 minutes to 12. So I'll have another 20 minutes. So I need to a little bit speed up. So this particular slide is important. So and hence I would like to spend some time here. And here you can see on the y-axis, you see that specific power, whereas in the x-axis, you can see specific energy, and you can see that batteries are coming somewhere here. So that means it has moderate specific power, but reasonably good specific energy. What does it mean is that if you use this kind of batteries, so when the specific energy is more, it means that for a given battery pack, you will get more range. Okay, because you are able to store more energy in a given weight of the battery. So you will get more range out of it. Okay, so specific power means during the drive cycle, So let us say you are driving on a highway and then you are trying to overtake one particular vehicle. So you require instantaneous discharge of that battery, giving more power to meet that particular requirement of maybe driving fast in a highway or overtaking. These are all the conditions where you require immediate power. Power means rate of change of energy. Okay, so immediately you need that particular power, and then here you can see that battery is coming moderate. Whereas fuel cell, you can see it has higher specific energy. So you can get larger number of range out of fuel cell, but fuel cell cannot discharge immediately. So that is the reason why fuel cell also requires battery, and battery has better discharge. So battery plus fuel cell combinations are required in commercial vehicles, making it even more costly. So here you can see this is a very new technology happening, what we call the supercapacitors. So the capacitor, as you know, has the ability to store energy in the electric field, whereas battery stores the energy in the chemical field. So battery stores energy chemically, whereas capacitors stores energy electrically in the electrostatic field. So what happens is that in our electronic circuit, you know that capacitors are used for charging and discharging very quickly. The value of capacitance there is microfarad or maybe picofarad to 10 power minus 9. So whereas supercapacitor, the capacitance of supercapacitance is in terms of thousands of farad. That means almost 10 power 9 powerful than a small capacitor which you use in electronic circuitry. So the supercapacitor will look like almost like a battery, and then it can charge and discharge. The advantage here is that whenever a power requirement comes, it can immediately discharge and give you that power. So you can use a combination of supercapacitor and battery in very premium segment car, where you will get very good sporty behavior because it is able to discharge very high current, and you also get the required range because your battery is giving you specific energy. But supercapacitor plus battery will become even more costly. I think this can be affordable only in a premium segment vehicle. So the research is going on supercapacitor, saying that whether they can completely replace the battery. So that means you'll take a supercapacitor like a battery, put it in your vehicle, and because it has very high capacitance, probably it will discharge only in maybe some 6 hours or 8 hours you will get. During that particular time, you will get the required range. Probably you may be able to travel maybe 50 kilometer or 20 in that particular range only. But the supercapacitor also, people are doing a lot of research so that whether the supercapacitor can be replaced for battery, at least in certain segments where you don't require too much range. So these are all the additional things happening related to the battery. I spent more time on battery and the supercapacitor and fuel cell a little bit, mainly because these are all the areas where it is, as I mentioned, today the electric vehicle, one of the most important thing is battery, its cost, technology, endurance, and safety, and how the things can happen. Actually, the research is in this particular area, and that is the reason why I spent a reasonable big amount of time here. And here you can see battery management system, and here you can see that extremely important to keep the lithium ion within the operational limits of current and voltage and temperature. Battery management system also gives the control over the cooling system. By any chance, if the temperature goes high in the battery pack, immediately it will act the cooling system to add more coolant or maybe add the more coolant flow into it so that the temperature is well controlled. And here you can see a kind of a system. Here I would like to explain you just one point here, how the safety of the battery is taken care. So here you can see the battery cells are connected in series, and so many battery cells are connected. Please track the my cursor. So that all these battery cells are connected in series and coming here, and then it's again connected in series. So you have only one current measurement because the same current is going through the complete cell, but individual voltage are measured by the BCU, battery control unit, and then it goes. So what happens if contract number 1 and 2, when it closes, the battery is connected to the inverter. So where the inverter will convert this DC voltage into AC voltage and goes to the motor. Parallel to this, there is something called a big capacitor. And that capacitor is called a DC link capacitor. And you can see that when it is closed, so this capacitor is getting charged, and from the capacitor it goes to the inverter. What happens is, in case of a crash signal, the vehicle crashed. What happens? It is detected by this particular sensor, and that sensor will detect a crash has happened, and then the battery control unit immediately open this 1 and 2, isolating the battery from the rest of the vehicle. So battery, it will remain still at high voltage, but the battery pack has all the kind of safety precautions inside that particular covering. So that means nothing will happen to the battery even though it is remaining charged. But what happens is, you have the capacitor here. That capacitor is storing huge amount of energy. And if somebody comes and touch contact with that capacitor or rest of the circuit, so he will get a heavy shock. So what happens during this particular crash is that capacitor will get discharged to the electronic circuitry, which is used for the inverter, and inverter electronic circuitry or IGBT or MOSFET, which is used, has the capability to discharge that. Thereby, so entire systems other than battery, everywhere, it becomes less than 60 volt. Anything more than 60 volt is called high voltage. So it becomes less than 60 volt in order of maybe few milliseconds. So that is how, in case of a crash, the rest of the systems are taken care. But what happens is that if what will happen in a crash and then this particular battery got crushed together. So there are so many precautions taken over there that it will not crush. And if at all it crush inside the cell, there is separator, and there can be a very, very, very rare chance, because this is one of the most important validation that need to be done on a battery pack, that it is not catching fire in case of a car crash. Okay, so unfortunately I had to speed up once again fast because there is something called a state of charge. I have to explain a little bit about it. State of charge is nothing but, so when you see the state of charge is 100%, it is like a fuel gauge. How do you see the petrol availability in your car on your fuel gauge available in front of you in the dashboard? For an electric vehicle, you don't have the fuel, you have the SOC indication for the battery. So if the SOC is 100%, then your battery is fully charged, and then SOC indication 50%, 25% gives you an indication about what is the charge left in your battery. And accurate estimation of this SOC is very important. And what you have is only the voltage measurement, but SOC has a strong dependency on the open circuit voltage. So online, you have to keep on computing what is the open circuit voltage, and open circuit voltage and terminal voltages are different. Here you can see in this particular circuitry. So you will get the terminal voltage measured, but you have to compute, you have to solve this particular equivalent circuit of the battery to get what is the open circuit voltage. And from open circuit voltage, you will get what is the state of charge. So this computation is extremely important for the battery. So I'm not going to detail because this is a very important thing. And another important thing is state of health. What is the state of health of the battery? So because when you do charging, discharging, when you discharge so much of current, when battery operates at different temperatures, and if you do fast charging, all these kind of things deteriorate the battery life. And how do you know that what is my battery life? And this is also is done through some calculations. And one of the resistance called the charge transfer resistance, which is the resistance between the electrode and the electrolyte, is computed. There is absolutely no way to measure it. It has to be computed through an algorithm. And that calculation of that charge transfer resistance gives you an indication about what is the state of health of the battery. And there are many researches going on how to enhance this particular computations and so on. Now coming to the charger, again, I may not be able to spend too much of time here, but very, very brief information. You can see that during the initial period of charging, when you assume that the battery is empty, and during the initial period of charging, the charger will work like a current source, pumping in charge irrespective of the voltage build happening in the battery. Because when you keep on charging, the voltage will build up. So, but you're applying a constant current during this particular stage 1, so that irrespective of the voltage build happening in the battery, you are supplying constant current. But if you keep on do that, then I think there is a possibility that the battery will overcharge. So to avoid that, when it reaches some particular level of charging, so the constant current pushing will be stopped, then it will get into constant voltage mode. When you get into the constant voltage mode, the current going into the battery for charging will depend upon the differential of the voltage between the charger and the battery pack. So as the battery pack picks up more and more voltage, this current reduces, and then it gets into stage 3. Once it reaches very close to 100%, so then no charge is applied, so it gets into ready mode, making sure that the battery is not overcharging. So the charging system and the battery management system should have extremely good intelligence to make sure that the battery is not overcharged, because overcharging the lithium-ion battery again will result in fire. So this is onboard charger. Actually, you can have this particular charger inside the vehicle along with the BMS system, so that you can connect to an external AC power supply like any other 15 ampere source. And in this particular off-board charger, this particular charger, whatever I mentioned, the intelligence associated with the charger is outside the vehicle, and it is along with the charging unit. So there are different standards available, SHADEMO, CCS, for different kind of plugs, different kind of signal communication has to happen. So unfortunately, there is no uniform standard. I think this is going to be one problem. And here you can see V2G. V2G means in future, the vehicle is going to be charged from, let us say, microgrid. And this is another disruption happening in the power system, where centralized power system is getting converted into smart grid, where rooftop, you can have the solar power on your rooftop, and then you can generate the power and consume it locally. When such a system is available, it is possible that during certain time, if the grid requires, the microgrid requires power, the battery in your car can give power to the grid, and you can generate some money out of it. And then at appropriate time, through an intelligent system, the cars will get charged at a different period of time, so that every car, if starts charging, the grid will collapse. So you can have a kind of a intelligent mechanism where the grid is not overloaded, but at the same time, morning when you wake up, your car will be ready with the charge. So this kind of technology also is emerging. So now coming to the other component, the inverter component. So here I can go very fast and finish it in 5 minutes. So this is the inverter component, or the power electronics component, where you are giving the DC coming from these two yellow. You can see that in the inverter, this is the DC input, and here the 3 yellows here are the 3 AC output. So this AC output goes into the motor, and the battery is connected. Battery, after the DC link capacitor, it is connected to this particular link. So basically, it is 6 IGBTs connected in this particular fashion. Those who learned power electronics, this is a well-known technology where the DC can be converted into AC and then given to the motor. So there are, coming to the motor, another component. There are different kind of motor. You have synchronous machine, permanent magnet synchronous machine, externally excited synchronous machine, axial flow machine, induction machine, switch reluctance machine. You have different kind of machines, and you need to choose. Each has got its plus and minuses, and this is also a lot of research is going on to make these particular machines efficient machines. Actually, we cannot afford to have, even though electrical machines has the efficiency of 90 to 95%, even the 5% inefficiency, we have to try to reduce it as much as possible, because all these losses are actually supplied by the battery. Battery is the only energy source in your car, and naturally all your EV components need to be very highly energy efficient. So the research is going in various directions with respect to how to make these particular components more energy efficient, less cost, of course, and then less weight. And this is where actually a lot of research going on in this particular area. So this is an e-axle, another component, and where the e-machine plus power electronics plus the powertrain unit, everything can be integrated together into a single unit. This is another component. And I'm almost reaching to the end of presentation. So basically, we need to have, when it comes to the overall control of the electrical machine, so ideally speaking, maybe those who are with electrical engineering, they will be able to appreciate this. So they would like to make the AC induction machine to work like a DC separately excited machine, because DC machine has the advantage of separate field control and armature control. You can have a separately excited DC machine. You can have armature control keeping the field constant, or you can have the field control keeping the armature current constant. So in this case, you are able to separate the armature current from the field current, and that is a very big advantage of DC machine. Disadvantage of DC machine, it is having commutator, and it can have a lot of maintenance problem. It can have some spark during the mechanical commutation. So we wanted to make the AC machine to take the best from the DC machine. That means separately you can have field and armature control, but at the same time you don't have the commutation. The AC machine, you don't have the commutation. So we need to have a FOC algorithm which makes the AC machine to work like a DC machine, so that it is very easy to control. So for that you require the position measurement. It's a very advanced technology. Explaining this itself will take at least 1 hour. So, but I'm just giving you the information that, so this is what actually a lot of research is going over here with respect to enhancing this particular control algorithm, enhancing the switching strategy for electronics, so as to have the machine working with the highest efficiency, as well as the power electronics are working with the highest efficiency. So this I'll skip. This is the overall control scheme. Yeah, this is the torque speed characteristics which I was mentioning about. You can see that the torque is for electrical machine is remaining constant for a long speed region, and then it falls. And this is the constant power region, and this is the constant torque region. So before ending, so this is a university and industry collaboration happened in Germany. And here you can see that a particular vehicle which is used for a specific application in the post office in Germany. So the Aston University and Bosch came together and designed the entire system, and then they made this particular vehicle an electric vehicle. And I want to conclude this talk saying that we would like to have similar collaboration in India between industry and academia, and there are a lot of scope to do so many researches. And for the biggest thing is that for a given vehicle, you have different machines and different power electronics, and then you can have different topologies and then different battery chemistry. How do you select all these particular best things for a given vehicle? The simulation is the way. So you have a mathematical model for each of these components put together, how the vehicle is working. So these are all the research areas. So you can have a lot of work that can be done in the academia regarding vehicle engineering, vehicle control, CV thermal systems, electrochemistry, material science, power distribution, decentralized power, smart grid, power electronics. So these are all the electrical machines, e-drives, and then the machine learning and artificial intelligence, how you can use this technology in electrics. So these are all the areas where a lot of research is ongoing, and then we can do it. I have given a lot of reference here in terms of books, and then some materials available in online. So I wish that you will be able to go through this. I'll share the slides to everybody. So thank you a lot.
Thank you so much, sir, for your presentation.
Questions?
We did have one question from Neil, who asked if you could suggest something, anything with regards to cell connection process.
I did not get that.
His query just said, he said if there's anything you could suggest in terms of with regards to cell connection process.
Self-connection process. I didn't get. Can you please explain what?
I've asked him to explain the same, but
I'm sorry.
I don't think he's mentioned it. As we are pretty much very close to the beginning of the award ceremony, uh, we will have to end today's session. Unless you want to mention anything else before we end today.
Yeah. Any
Hello.
questions? So, anybody has any questions? You can also put in
No.
the chat box.
Right now, there aren't any. It was just that
Okay.
one question that had come in at the time.
I did not get that last word. Probably,
Yeah.
I think that's why I'm not able to answer it. So, if somebody can explain what it is, then
A
I'll be.
uh, cell connection process. I think in the beginning you were talking about battery
Self-connection.
cells and
This regarding what?
I think battery cells. This was actually much in the beginning when you had just started the presentation. That's when the question had come in.
Okay,
But
maybe I
I
didn't
don't
get.
believe
I
Neil
don't
is
want to make
online
a
right now.
guess. Okay, what is self-connection? What he meant by
Sure,
that? Maybe I am not sure
sure,
about in what context he asked that question. Sorry.
for sure.
That
Yeah.
I don't want to make any guess what could be and then try to
Yeah.
answer something. Okay, so basically the last statement from me is that the concluding remark is that, as I mentioned, in battery and all these particular components, enhancing it, simulation and vehicle level simulation. Actually, a lot of simulation can happen in the EV systems and the thermal management system. I put all this particular topic, and then I would
Yes.
encourage you to take some additional courses or whatever, so that this is definitely going to be a futuristic business. So wish you all the best in whoever is interested in this field of electrification.
I would say more than futuristic, it is current and present as well. Wouldn't you agree?
Yeah.
Especially the EV industry and how much the government has been inputting in that segment in India has been huge. So yes, you are definitely right that participants should start taking an inclination towards this, especially because there are more job opportunities coming along in this sector as well.
Yes.
So
It is
Pradeep
for
sir, thank you.
faculty also. It is also for
Yes,
the faculty, not for the students alone, to choose out of this
right,
particular topic, certain topic for the research, and make research more oriented towards the industry requirement. So I think that also
right.
is going to help.
For sure. More R&D in this specific segment, especially in India, would be definitely great for future growth as well. Thank you so much, Pradeep sir. Pradeep sir, we really enjoyed this overview that you provided today, and I'm sure the students will benefit from the same. To all our participants on YouTube, thank you for joining in. We hope to see you today at the awards ceremony at 12:30 p.m. To everybody, until then, thank you.
Okay, thank you.